Okay guys, we are going to do the CA review. I will put the answers, all the answers on a blank sheet, so this is just the review. I'm just going to pick a couple of questions and work those out. So the first question is going to be number 1. I'm going to go fairly fast, but if you have any questions, by all means come in and see me tomorrow. Okay, which graph represents a function with the domain of all real numbers greater than or equal to -7 and less than 2? So when it's talking about the domain, we know it's talking about the x values. Okay, so when we're talking about the x values, we're talking about everything on the x-axis. Which of these graphs cover the domain of -7 to +2? So basically it's saying -7, x, and 2. That's what it's saying. It's greater than or equal to -7 and less than 2. So which of these graphs? And that would be this one right here. The graph covers from -7 all the way to +2. All of these numbers are covered by the x. That's number 1. We're going to skip number 2 for right now. We're going to go to number 3. What is the range of this quadratic function? And there's 2 ways you can do it. If you know that this has moved your quadratic function up by 1, you can look at that and say, this is the parent quadratic function, and now it's being transformed up. It's been moved up. So the range is talking about your y values. So now my graph, instead of looking like this, it is being moved up like by 1. And so it's going to look like this. And one thing that you can do is just plug that equation into your calculator and go to your y equals and go to x squared plus 1. Enter and graph and see. There it is. It's moved up 1. Sorry about that. It's moved up 1. All right. Then I can see all of my y's are covered from 1 on up. So the answer is all real numbers greater than or equal to +1. There's your answer. Moving on. Okay, the graph, sorry, there we go. The graph of the quadratic function g is shown on the grid. The coordinates of the x-intercepts and the y-intercept and the vertex are integers. They're just saying that they're whole numbers. Okay? What is the maximum value? Well, we know that since it's facing down, this is going to be a maximum. The maximum we know is going to be the largest y value. What is my largest y value? Right here, it is 9. Okay, that would also be my vertex. Looks like it is 1, 2, I think 3, 9. The largest y value is just 9. That's all you need to put. Okay? Moving on. This is your vertex. Okay. If you have points 3, 2, and 7, 2 are on graphs of the quadratic functions f and g. So I've got a graph. And we know that f goes through 3, 2. I'm just kind of figuring out that's about 3 and that's about 2 and 7, 2. So those are the 2 points. Then I know that F opens downward. So it's going to look a little bit like this. And I'm just kind of judging from what the information is that they're telling me and kind of creating this picture. I know that it opens downward. Then they tell me that G goes also through those points and it opens upwards. So I'm just going to kind of say, all right, that's going to look a little bit like that. So which of these statements are true? Well, do they have the same axis of symmetry? If they both go through those points, then yes. So that would be true. The graphs of F and G have the same x-intercepts. Do we know that they're going to cross the x-axis at the same point? No, they don't. So that is not true. Do you see how much easier it is once I write a visual, how much easier it is to answer these questions? Because now I have an understanding of what the situation is up here. The graph of F, which is my pink, this is G, the graph of F has a maximum point, and the graph of G has a minimum point. Is that true? This is a maximum, and yes, this is a minimum. So that is true. And the graph of F is a reflection of across the x-axis. Well, we don't know that because it does not reflect across the x-axis. It is not a perfect reflection. So we're going to say no to that. So the answer is 1 and 3. Okay, moving on. Here we have the graph of is shown on grid. Now we can plug this into our calculator and we should get the same visual on our graph. What would help us understand, but we're looking for the zeros, okay? The zeros are not whole numbers. They go in between those. So we're going to look at that and we're going to see, is 3 a zero? No. Because we know that zeros are when y equals 0. That's how it gets its name. When y equals 0, those are our zeros. It's also our solutions, our roots, and our x-intercepts. These all mean the same thing. So the zeros, 3 is not a 0. 2 and 9 are not zeros. 9 is not even on the graph. 11 over 12, well, that may be a good answer, but there's only one of those. So we know that there's 2 places where it crosses the x-axis. So we're going to cross that one out, and that leads us with that. But before you move on, I would ask myself, does that make sense? Does it make sense? Is that about 1/3? Yes. Is that about this equals 1 and 1/2? Is that about 1.5? Yes. So there I feel confident putting that as my answer. Okay, let's flip on to number 8. Okay, the quadratic function shown on the grid. What is a solution? Where Rx equals 0. I don't even know what that means. No, I do. All right, when Rx equals 0, this is also saying when y equals 0. Solution, roots, x-intercept, zeros, all the same. So I know they're talking about this point and this point. Okay? They're trying to fool you because this, of course, crosses the y-axis at -50, but we are not going to be fooled. We are looking for our x-intercept, where our x's cross. So we look and it's at -6 and 14. So we cross that off, cross that off, cross that off. We know that it's that one. Okay? Which statement about the quadratic functions are false? So we're looking at the false one. I will tell you the easiest way when you're given multiples, plug these into your calculator. Use your calculator. You have the benefit of having it. So you can go to y equals and plug everything in. Negative, and I'm going to use my decimal point because I know that 3/4 equals 7/5, but you could put parentheses 3 divided by 4, and a parentheses, well, I'll do that, x squared. I'm putting this in parentheses so I know that it's going to use it as a fraction. You could also put in 0.75 if you wanted. So there's my first equation. My second equation is negative 2x squared minus 5. And my last equation is 1/4, 1 divided by 4. Oh, I gotta use my parentheses. Parentheses 1 divided by 4 x squared. The reason why I'm using my parentheses is if I don't use my parentheses, it may think that that x is on my denominator. So I need to make sure that the calculator knows I'm talking about 1/4 if I'm using it in fraction form. If I'm putting 0.25 in as my 1/4, that's fine. Plus 1. Now, I'm going to watch this, and as it graphs these three equations, it is going to graph them in sequence. So it's going to graph this one first, then it's going to graph this one first, second, and then it's going to graph this one last. So when I press graph, that is this one, that second one is this one, and that top one is this one. So now I've got all three graphs on my screen so I can look and compare and answer these questions. So put it like, I don't know how to put it so you can see. So the graphs of two of these functions have a minimum point. Is that true? This one has a minimum, this has a maximum, this has a maximum. Well, that's not true. So I'm going to cross that out as not being true. Do the graphs have the same axis of symmetry? Yes, all three graphs have the y-axis as the axis of symmetry, so that is true. The graphs do not cross the the graphs of two do not cross the x-axis. This one does not cross the x-axis, and this one does not cross the x-axis. So yes, two of the graphs do not cross the x-axis. And the graphs have different y-intercepts. Do all of the graphs have different y-intercepts? Yes. So the one that is false is A. So that is my answer. Okay? Make sure you understand if they're asking if it's false or true or not true. Okay, moving on. The graph of the quadratic function g is shown below. Here you go. This is g. Based on the graph between which two values of x is a 0 of g. So here's a lot of vocabulary, and if you don't know what 0 is, you may be confused, but we know that zeros mean x-intercepts. So between which two values? Is it between negative 9 and 8? No. Is it between 1 and 2? No. Is it between negative 7 and negative 5? No. Is it between 4 and 5? Yes. So really, a lot of these questions are judging your vocabulary and whether or not you know what they're talking about. Moving on. The table of the values for the quadratic function of g is shown below. If 1 is a solution to g of x equals 0, what would be the other solution? Okay, again, we're talking about solutions. We're talking about y equals 0. We're talking about roots. We're talking about x-intercepts. So when is y equals 0? Well, we see that y equals 0 here. They're telling us that when x is 1, y is 0. And right here is the other one. So the solution is 3. Where is y equals 0? This is your x, this is your y. Okay? Moving on. What is the vertex of this graph? There are lots of different ways to determine this answer. The easiest, quickest, most correct, or easiest way to get the correct answer is basically you just plug it in your calculator. So I'm going to clear all these. I'm going to throw in the equation just as it's written. X squared plus 6x plus 10, and go to my table. But that's all well and good, but if I don't know what I'm looking for, I won't know what to think of. So I may go to my graph and see this is my vertex. It is right around here, and I'm going to even just kind of count. Oh, there's a smudge. I'm going to even kind of count. Sorry, trying to get this clean for you guys. I don't know if that made it worse or better. 1, 2, 3 over. So I'm now going to look at my table. I'm not going to go on that. I really want to look at my table and know that about -3 was where it looked like my vertex should be when x was -3. And sure enough, it goes from bigger to smaller, and then it starts getting bigger right at -3, 1. So that's going to be my vertex. Do I see it? -3, 1. Perfect. Done. Check it off and move on. Okay, let's go on to, again, what are the x-intercepts of this? So again, I'm just going to plug this into my calculator and do 5x squared plus 4x minus 1. I'm going to look at my graph just to see about where should my x, what does this kind of look like? And this is kind of a mess, but I do see that one of my x-intercepts is right around -1, and the other one, I can't really tell if it's at 0 or what. So I'm going to go to my table, and I'm going to look and say, okay, yeah, -1 is one of my zeros because this is when y equals 0. Y equals 0 here, -1. So now I'm going to look at my answers, and I'm going to say, okay, this one has a -1, this one has a -1. So I can cross these out. I know that these are not the answers. However, this has a 1/5, and this has a 0. However, according to my table, when x is 0, y is -1. So that is not a 0. This is my y-intercept. That is not a 0. My y has to be at 0. And it doesn't show me another 0. But what it does show me is it goes from negative to positive in between 0 and 1. So some point between 0 and 1, I know my graph is going from negative to positive. So what that's telling me is some point between 0 and 1, it's going from negative to positive, which tells me that it has to be here. 0 is not going to be the answer. Okay? You kind of have to do some looking, and if you go to your graph, you can see, you can even trace and go up and see that when y is very close to 0, I don't know if you can see that, x is at 0.2, which is about 1/5. And I just do that on my tracing and use these side buttons to help me trace. Okay? Use your calculator. It really is going to provide you with a nice little resource. Okay. The function of this graph is below. I'm trying to get it in there. All right. So, what function is best represented by this graph? Well, we know, and this is our vertex form. Okay? So, we know that they're all going to be negative because it's facing down, but we see that these two are not in vertex form. So, right there, oh, that's okay, never mind, okay. But we can do a few things. You can plug all of these in your calculator and see if you get this same graph. That's one way to do it. Plug every single equation into your calculator just as it is and see which one matches this one. Another option is to say, I know that when I have this, that's going to move it to the left 1. This is going to move it up by 4. Okay. This would move it to the right by 1 and up 4. But it's my vertex is here. So if I plug these in my calculator, y equals Claire, let's see, I'm trying to figure out how to do this so that you guys can see everything. It's Claire, negative, parentheses, x plus 1. I'm going to plug this one in because this is the one that I think it is. It's moving it to the left, just as we think, and it's moving it up 4. So I'm just going to plug this one in my calculator and see if that's accurate. Plus 4. And then I'm going to graph it, and I'm going to look and see. Does that look right? Well, it looks close. So I'm going to go to my table and see, is my vertex actually negative 1, 4, just like it shows in the picture? And yes. So then I'm going to go ahead and pick F. This should be your answer. Moving on. Let's just do this one real quick. I didn't really go over this one. 2 points of the graph are shown on the grid below. What is the equation for the axis of symmetry? Well, if this is here and this is here, all I need to know is that your axis of symmetry is going to be halfway in between. So you literally can count 1, 2, 3, 4, 5, 6. So I'm going to go 3 in, 1, 2, 3 in here, 1, 2, 3 in this way. That's at negative 3, so it should be x equals negative 3. It's always x equals, never, ever y equals, because y equals goes horizontally. All right, moving on. Number 17. The graph of f of x, so here's the parent quadratic function. All right. Which statement about the relationship of this graph and the graph of 7x squared is going to be true? Well, what do we know? Plug it into your calculator. How many times have I said that? You guys, go ahead and take your calculator and plug in, clear, x squared. Move that down, 7x squared. Graph them. See what happens. There's the x squared. There's the 7x squared. What just happened? The graph got narrower. So there's my answer. It's not wider. It didn't move below. It didn't move above. Okay? Moving on. Which function graph has a vertex at 3, 5 and contains that point? Okay, so one thing that you can do is if you know your vertex form, you're going to know that this would move it left by 3. This would move it down by 5. If my vertex is 3, 5, I actually want it to go right and up. This would move it right by 3 and down by 5. So I know neither one of these are going to work. This one would move it to the right by 3, so that's good, and up by 5. All right, well that's looking good. This one's going to move it left by 3 and up by 5. However, sometimes I get my right and my left mixed up, so I want to make sure. So what I would probably do is just, again, plug it into the calculator, clear, go, 2x minus 3, I'm going to check my squared, plus 5. I'm going to clear this one. And I'm going to graph that and see. What does that look like? Okay, is my vertex 1, 2, 3, and about 5? That looks about right. I don't know. It's looking good. Does it go through that point, 5, 13? Well, if I go to my table, I can go down and see. Number 1 is my vertex at 3, 5. I'm starting at 23. I'm getting less, 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 and now it's getting greater, greater, greater. So I do see that my vertex, yes, is at 3, 5. Secondly, there's my x, there's my y. This is what they want. So yes, it is that one. What if I would have plugged this one in? If I changed it and went to my table, I'm going to look and notice, oh, that's negative 3. 5 is my vertex. That's not what I want. And not only that, but when I go to my x is 5, it's 133. So that I don't want either. So you can very easily plug all these 3 in and just look at this point and see if that's covered by the table. All right, moving on. Let's do number 20, I'm sorry. Number 20. Function p is in the form of y equals ax squared plus c. If the values of a and c are less than 0, which could represent p? So what that's saying is a is less than 0. So what is that saying? It's negative. It's negative. What happens when your a is negative? The parabola faces down. So this one could be it. This one could be it. This one could not be it because it is facing up. So I'm going to cross that one out. This one could be it. Okay? But my c also is less than 0. Which means what? That this is going to be minus a number. I don't know what that number is, but I also know that when in my vertex form, if I have it go minus a number, then that shifts my parabola down. So this one is a positive y-intercept. So I know this one's not going to be it. This one could be it. And this one is actually at the origin. So this one has not been shifted down. So my answer is going to be H. Do you see how if you just take the things that you know that this being negative, if they're less than 0, they're going to be negative. if this is less than negative, or if this is negative, it points downward. If C is negative, it shifts downward. All right, moving on. Which statement about these are true? I'm going to plug this into my calculator, and I'm going to get clear negative x squared minus 2x plus 15. And I'm going to go to my table, and I'm going to look at -3, -5, -5, +3. I'm going to look at these zero numbers and see which of these happens. Oh, that's interesting. Did I plug that in correctly? Oops, I did not. That needs to be 2. Delete. I didn't plug that in. I got some errors, so that showed me that I plugged it in incorrect. And it's okay. Go back and check and make sure these are the same. Absolutely make sure that your equations are the same. So go back to my table, and I'm going to look at 3. That's a 0. +3 is a 0. So I can immediately cross out this one and this one because I'm looking for a +3. I'm looking in my y column. Where is my y equal 0? Now I'm going to look and see, okay, I think it should be, well, here's +5. That's at -20. So +5 doesn't seem to be it. And, let's see, -5 is it. There isn't even an option there. This should be -5. Oh, there, yeah. There you go. So there's -5 and 3. You can't use +5, so there you go. There's your answer. Just go to your table and see, where does y equal 0? That's going to give you your zeros. All right, moving on. Almost done. Here, the quadratic function graph is on the grid below. If this function is written in our vertex form, right, this is vertex form. This is the form that we actually like. Even though it looks kind of crazy with these letters, this is the form that we like. What is the value of A? Well, we know that A has to be positive. It has to be, A has to be greater than 0 because it is facing up. If it wasn't facing up, if it was less than 0, then it would be facing down. So we know that A has to be positive, even though the vertex is in the negative quadrant. The A is positive because when the A is negative, it faces down. So by this graph, we know A is positive. So we can automatically cut out those two. We also know that as A gets bigger, it gets more narrow. So you know what I'm going to do? I don't know what it is between these two. So I'm going to graph it. And I'm going to say, okay, y equals, and I'm going to just do 2x squared. How does that compare to 5x squared? And how does that compare to my regular x squared? How do these all compare? What does that look like? And if you think about it, I know that my vertex is at -5, -8. So I could rewrite my vertex, I could rewrite this equation and say, if it were 5, my equation would be 5 times x plus 5, right? Because it's moved to the left 5 and it's gone down 8. Or it could be, oops, 2, I've moved it over 5, down 8. So these are the two equations that I'm trying to figure out which of these graphs is. So I can even go back up here and change that and say, all right, parentheses, x plus 5 in parentheses squared minus 8. And then change this one to parentheses x plus 5 in parentheses minus 8. And I'm going to clear that one and say, all right, let's graph both of those. That's the first one. That's the second one. Okay? But I'm not sure which is which. This one goes through, my zeros are -7, -3. So I really want to go look at my table. So I'm going to look and see which one goes through zeros of -3 and -7. Y1 goes through the 0 at -3. Let's see if it also goes through at -7. Oops. And -7. So Y1 is going to be my answer because I plugged it in and I am seeing that these are my zeros. What is Y1 again? That was this one with the 2. That's a little complicated as far as getting there, but it's kind of like a puzzle, all right? You have to just say, what's gonna work in there? You can do these equations very quickly. Those are not difficult when you know your vertex form and you shift it. All right, moving on. I think this is the last one, so hang in there with me. What is the floor? Okay, the floor plan of this storage facility is in feet. So basically it's saying multiply 5x plus 4 by 4x minus 4. You get 20x squared, 16x, -20x, and -16. So the answer would be 20x squared. Then we're going to combine these two, minus 4x minus 16. So, now, what if this was a triangle? What if we were trying to find the triangle? We would have to divide this whole thing by 2 because this would be your base, this would be your height. How would you divide this whole thing by 2? You basically just get 10x squared minus 2x minus 8. Because to find it's 1/2 the base times the height for a triangle. This would be area equals length times your width. Sorry, I didn't start off that way. You're doing your length times your width. So when I multiply those out, that's what I get. If I was going to do a triangle, this would be a triangle. All right? All right, guys. Hope that helps. Take care. Study.